Okay, 23. This one requires some calculation. Sorry, not calculation, some working. So let me just screenshot this question 23. Okay. Okay, let me screenshot this guy. Okay, you are given. Oops, it's a bit too large. Okay. Oh, never mind. I don't have the answer here. Okay, let me just work out the answer for you. The question says, based on the circuit below, what is the correct value to write to port B to turn on LED 1 and... Okay, I want to turn on LED 1 and 3. I want to turn this one on. I want to turn this one on. Okay, you see the connection this way. This is the so-called anode. Okay, and this is the cathode. Current can only go A to C. Okay, if you have trouble remembering, just remember A, B, C. Okay, A first, then C. Okay, so the current must go in the direction of this arrow here. Okay, so how can you make the current go this way? Okay, if you want current go this way, okay, you want the LED to turn on. This point must be low. Okay, because this actually this one should be 3.3 volt. Okay, somehow it's a old. For peak 18 you use 5 volt, but STM32 is 3.3 volt. Okay, so you want this LED to turn on, you must output a 0 here, or logic 0 or 0 volt. Okay. Now I also want this one to be turned on, so here should be 0. Okay, here I want it to turn off, high. Okay, 3.3, here is also high, 3.3, so no current will flow. Okay, this one also will be off. Okay. So the answer should be 1010. Okay, so I want 1010. Okay, this is the binary. Okay, the front part I don't know what number, because I don't know what I connected to PB4 to higher. Okay, so if you write in hexadecimal, this number, okay, 1010 is actually A. 10. Okay, this one again I don't care. Okay, so I want A. Okay, this one is the answer. Okay, first one happened to be the answer. Okay, A, correct. Okay. I think the thing confusing is they put the pin this way, 0, 1, 2, 3. But here is 0, 1, 2, 3. Okay, can be confusing to some student. Okay. Okay, next one. Okay, this is a calculation question. Okay, so I think it's quite simple. Let me just screenshot again. Okay, just to show you the answer. Okay. I have a LED, okay, and then there's a 470 ohm resistor. Okay, I think you need to know that. First thing, I want to turn on this LED. Okay, the current must go A to C. Okay, this way. Okay, A first, then C. Okay, now there's a 470 ohm current limiting resistor here. LED has a voltage drop of 1.9 volt. Meaning that comparing the two ends, okay, there's a voltage drop of 1.9 volt from the plus to the minus. Now, STM32, when you want to produce a 1, you output 3.3 volt. Okay, so this one 1.9 volt. Okay, how much potential drop over this one? How much voltage drop across this one? So the answer is of course 3.3 volt. You subtract 1.9 volt. Okay, this will give you the voltage drop across the resistor, and then you divide by the resistor. Okay, by Ohm's law, this will give you the current. Okay, so I forgotten. I think it should be 2.98. I think we have this question in the tutorial. 2.98, correct? Okay, question 24 is 2.98. Okay, so A is the answer. Okay, simple calculation. Okay, actually the tough question are towards the end. Okay, now this one, okay, let me just screenshot again. I'm doing more and more screenshot, meaning the question become more and more difficult. Okay, okay, this one say there's some code segment given here. Okay, you want to toggle LED at PB14. Okay, I think there's some LED declare. if the LED is to blink, okay, this is the critical thing. You want to blink at frequency of 2 Hertz. Okay, meaning that okay, if your frequency is 2 Hertz, I'm sure you know period is 1 over f. Okay, is 0.5 second. Okay, 0.5 second. Okay, 1 over f 0.5. Now you want to blink at 2 Hertz, meaning that like that. Okay, each of these pulse here, okay, is 0.5 second. Okay, off, on, okay, you bring at 0.5 second means off and on together is 0.5 second. Then each of these segment here, okay, should be 0.25. Okay, so the answer, okay, maybe I just read. Actually this if should be small if. Okay, this dot read, okay, for digital is actually optional. Okay, equal to 1 if you press the switch. I will invert the LED, wait for, okay, this one should be 0.25. Okay, so this one should be 250 millisecond. Okay, unit is millisecond. Okay, so on and off, it will give you 0.5. Okay. So I think the answer is D. Okay, let me check whether D is 250. Yeah, 250. Okay, D is the answer. Alright, halfway done. Okay, you can always pause the video and watch again. Okay, continue watching. Okay, let me just zoom out. Too small. Okay, you look at this one, question 26. Now this is the so-called bidirectional DC motor controller. Okay, so I actually have 4 transistors. Okay, now this one is a bipolar junction transistor. Okay, you can turn it on and off by outputting 1 or 0 here. You output a 1, okay, transistor turn on, okay, then the current can flow. Okay, so now the question say, why is it called a H bridge? Because it look like H. Okay, H. Okay, now you want the motor to turn counterclockwise, okay, or reverse direction. If you pass the current from plus to minus, okay, you will turn clockwise. Okay, if you pass current from minus to plus, okay, you will turn counterclockwise. That means the current must go this way. Okay, current must go this way. Now for the current to flow this way, the path is actually like that. Okay, through that transistor, okay, to the motor, through that transistor, then to ground. Okay, one more time. You want motor to turn counterclockwise or reverse direction. The current must go from minus to the plus. Okay, the current must go this way, minus to plus. Okay, so you must turn on that transistor. Okay, because this is a high voltage. Turn on that transistor. Okay, go through from minus to plus, and then through this transistor, which must be turned on, and then to ground. Okay, so you need switch 2 and switch 4 to be turned on. Okay, and the others off. Okay, so the answer should be this guy. Okay, this one. Okay, switch 2 on, switch 4 on, and these 2 are off. Okay, now 1 and 3 off. Okay, I'm sure you know that if you want to turn it clockwise, this is counterclockwise. You want clockwise is plus to minus, then the current has to go this way, exactly opposite. Okay, this way. Okay, let me show again. From the high voltage through the transistor at switch 1, okay, plus first, then minus, and then through the transistor at switch 3. Okay, so but this question is asking counterclockwise. Okay, so B is the answer. Okay.